the sine and the cosine, the sine and the cos graphs, both look very similar. They both look like this. Okay? So it's an up and down curve. And what this is just some terminology to recognise. So this is what they're referring to as the principal axis. So that goes through the centre of this curve, cycle, yes, whatever you want to call it, function, wave, sure, love all those words. This is what we would call a minimum point. We talked about those from quadratic graphs. And this is a maximum point, obviously. This is what we call a period, okay? Period. And it's how long does it take to do one full cycle? So the graph is going on and on and on, it's just repeating. But this is how long does it take to do one full cycle? Okay, you all happy with that? This is known as the amplitude. In other words, if this is the maximum and this is the minimum, then it's half that distance. Okay, so that's what we refer to as the amplitude. Alright, so that's just some terminology for you. It's all defined there. So let's have a look at the sine x graph. So this is y equals sine x. Now, I had drawn it for you because, quite frankly, I didn't really think it would be very useful for you to plot them. However, I could have got you to have a table of values, and at every 15 degrees or so, got you to type sine 15, sine 30, sine 45, and you would have been able to plot these points. Okay? So that's how these are formed, but obviously it does take a long time. I don't think it's that useful. So, the period, as we said, how long does it take to go through one full cycle? So if this was my starting point, this is 0. Oh, now I should point out, along here at the bottom is 90, 180, 270, 360. Hopefully you can read those numbers. And they are all degrees. Okay, so this is in degrees. If you take this, take maths into the next level, you'll start looking at a different angle measure, but for now we're looking at degrees. And that's why, remember, it's important for calculators to always be in degree mode. Okay, so we're in degrees here. So how long does it take to go through one full cycle? If this is your start, if this is 0 or we're starting, up, down, up, how long did it take to get through one full cycle? You got a question or you were answering me?
Well, I can't answer you now.
No, but I was just checking it wasn't a question. It was shouted out, yeah. 360 degrees. You all happy with that? Hopefully you can see the values for the amplitude. What's the amplitude of this graph?
4. Oh, sorry. Oh, 1, sorry.
1. We all see that? So it goes up to 1 and down to -1. So our amplitude is going to be 1.
That's not in degrees.
That's not in degrees, no. Just the horizontal. Cosine looks really similar, yes? Bless you. Cosine looks very similar. And our period. So if we were to say this is our starting point, again we need to do a full cycle. So in this one, we finish this cycle here. How long does it take? 1 minute, 360. And what's our amplitude? 1. Okay. So they both have a period of 360 and an amplitude of 1. So what's really different about them? Well, this one here starts at 0, 0. Okay? The other one starts at 0, 1. Okay? But everything else is the same. It's a shift along. How do you remember that? Well, this one here, we tend to say makes an S through the y-axis, so that's an S for sine, and this one here makes a C through the y-axis for cos. Okay, so the sine through the x-axis and the cos through the y-axis, y-axis. Right.
Why is it 1? Because 1 subtract 1 is 0.
What do you mean?
The amplitude of 5.
Because from this measurement here is 1 unit. So total, if we were trying to say, well, what's this measurement, then it would be 1 subtract negative 1, which is 2, and half of that is 1. Yeah. All right, so that's sine and cos. Very similar, other than, and it's a shift. One starts at 0, 0, one starts at 0, 1. Mr. Tan graph is different. Okay, so Mr. Tan graph is different. Hopefully you can see where a cycle finishes for him. So, whoosh, now. This would be his cycle. So how long does it take to do a cycle for Mr. Tan graph? See? If we think about this one here, so this is 90, and it goes to 270. How many is that? Pardon? 180, yeah. So the period for the tan graph is 180. So it repeats every 180 degrees. What about my amplitude? Where does it keep? Now, I have to say, this says 2, 4, and this sequentially keeps going. Is there an amplitude? No. So we wouldn't discuss amplitude when it comes to the tan graph. But, yep. I don't know why. Elena?
So do tan graphs always have no amplitude?
Yes. So, you may or may not recall, when we were looking at trig, so SOHA-TOA, and I was saying to you when you, if you've got your opposite over your hypotenuse, for your sine and your cos graph, that value had to be less than 1. So if I said to you, you had that sine of something was 7/4, I'd know that that was wrong. Because the sine of any angle cannot be more than 1. So this always has to be a fraction, and it can't be an improper fraction. So if you were choosing your opposite and hypotenuse and got the wrong way round and wrote 7/4, we know it's wrong because it's more than 1. And if you try to do inverse sine of 7/4, it will tell you it's impossible. So that's the same for the sine and the cos. They can only have a maximum value of 1. For your tan, it can be anything. Okay, so it has a bigger number. Yes.
For this tan graph,
Yep.
is it like a called have the time undefined number?
Yes. So I've said here, do you remember I just said in the last pack about that axis being an asymptote? Here, we talk about asymptotes again because the tan graph has undefined moments at 90, at 270, and negative 90. And in fact, every multiple of 180 from those, okay? So here, these are all asymptotes. And if you typed into your calculator tan 90, it would say it was an mathematical error, that there wasn't such a value, okay? So they are known as asymptotes. We normally show them with dotted lines, which is the way I've done. And it means that there is no value for that, that there is no answer for that value of degrees.
But there's one optical 89.
So you could do tan of 89.99999, it will give you 1. You can do tan of 90.0000001, and it will give you 1, but not 90 itself. Okay? Now, it tends to be, so this is something new into the EdXL exam this year. Okay, so actually looking at the tan graph specifically. Not the tan graph, the trig graph specifically. So it's going to probably be that you just needed to recognize them rather than anything else. But I'm gonna go through a little bit more about the transformations of them as well. Oh wow, this is quite complicated. Alright, I'm hoping it's going to become clearer. I've tried to use colours to help. Alright, this graph here we know is the sine graph because look, it's making the S through the axis. Okay? And if you recall, no, maybe not. Alright, if I was told that, if I couldn't myself into that,
Yeah.
is that underneath?
No, it's fine.
No, alright, yeah, okay. So if I typed into my calculator sine 65, so I'm choosing this value of 65 here, I would get an answer that's probably about 0.8ish. Okay, so I don't really know what it is, but it's going to be about there, because I can see that that's where it hits my graph and it comes along here. Can you see that this portion of the sine graph is symmetrical? Yes? So this essentially is a line of symmetry through here. Which means that if this value here represents 65 degrees, then this portion here would also represent 65 degrees. Do you see that? Yeah? So that means that this value here, the 115, must also give me the same value. So if you typed into your calculator sine 65 and sine 115, you will get the same answer. Okay? So it's just showing you that the sine and cos and tan graphs, there are multiple solutions if you were asked to. So at the moment, we may have been told sine theta equals 0.87, theta equals sine to the minus 1 of that, and we would give an answer. What we're saying now at this level is that there's secretly lots of solutions that will give you that same answer of 0.87 because the graph keeps going on. And it keeps going on back here as well.
So why does the calculator give you one?
Because your calculator can only give you one, and it will always give you an answer closest to this area here. Okay? So your calculator is only human. It's only capable of giving you one answer. You have to know how to find the other one. Stop laughing. Yes. No, so if you did the inverse of 0.87, it will always tell you the same value. Similarly, if we were looking at a negative value down here, okay, and we know that this value right here is 250, then what you're trying to do is to say, okay, well if this represents 250, I can see that I've got another symmetrical bump here, and here's my line of symmetry. So whilst I know this is the value 250, because obviously it's going from 0 up to 250, I know that this portion represents 70 degrees. You'll see that? Because this is a value 180. So this portion must represent 70 degrees. So therefore this portion must also represent 70, which gives me a value of 290, which tells me again that sine 250 would give me the same answer as sine 290. Okay? So this is just kind of showing you a little bit about the graphs and how they are symmetrical. The cosine one is a little bit easier, simply because we've got just the one line of symmetry. Okay, we can see that through this line of the 180, it's completely symmetrical. So if you had a value of cos 45, I would know that cos of 315 would give me the same answer because of the symmetry here. Yeah, see that? For the tan, if this value here is 65, then we know this graph repeats every 180 degrees. So therefore this value here of 245 would also give you a value the same. So tan 65 is the same as tan 245. So it's all really looking about symmetry and how the graphs are repeating over and over again. Repeat.